All right, let's talk about something incredible. An invisible force that, and I mean this literally, powers our entire world. It's the magic that happens when you mix a magnet with a little bit of motion, and yeah, it's the reason the lights are on for you right now. So how does this all work? Let's dive in.
And this quote, it just perfectly captures the spirit of the guy who figured this all out, Michael Faraday. Now, what's so amazing about Faraday is that he had almost no formal education. He was an apprentice in a bookbinding shop. He basically taught himself science by reading the very books he was supposed to be binding. His whole life was proof of this idea, that even the most mind-blowing things like making electricity from a magnet have to be true if they follow the laws of nature.
But think about that for a second. How can a simple, moving magnet, a little piece of metal, generate enough electricity to power an entire city? It just seems impossible, right? That a simple magnet and a coil of wire could hold the secret to our entire electrical grid? Well, that's the big question we're going to tackle today.
And to get there, we've got to rewind the clock. Let's go back to the early 19th century and really understand the puzzle that was driving scientists completely crazy.
So back then, everybody knew that electricity could create magnetism. You run a current through a wire, and poof, you get a magnetic field. It was a well-known trick. But Faraday, he couldn't stop thinking about the reverse. He became totally obsessed with this one question. Could a magnet somehow create an electric current? He spent years trying to figure it out, and for a long, long time, nothing.
And then, almost by accident, he stumbled upon the secret ingredient, the key. It wasn't just about having a magnet near a wire. The real magic was in the motion.
The year was 1831. This is it. After all those years of trying, Faraday finally cracked the code with this beautifully simple experiment that was about to change the world forever. Okay, so this breaks down his incredibly simple but brilliant experiment. First, look at step 1. He just held the magnet still near a coil of wire. And nothing. The meter reads 0. Dead still. But then, and this is the aha moment in step 2, the second he pushed the magnet into the coil, the needle jumped. Bam! We have a current. Then, for step 3, he pulls the magnet back out, and the needle jumps again, but this time in the opposite direction. The takeaway here is huge. It wasn't the magnet itself. It was the motion, the change in the magnetic field that was creating the electricity. And he gave this incredible phenomenon a name, electromagnetic induction. Put simply, it's just the process of making an electric current by changing the magnetic field around a wire. He'd done it. He had proven, once and for all, that magnetism plus motion equals electricity. But, a discovery like this just opens up a whole new can of worms, right? New questions. Like, how much current can you actually make? And why does it flow one way and then flip to the other? Well, it turns out, nature has some very, very specific rules for this game. The first rule is Faraday's law. And this one basically tells us how much. It's actually really simple. The faster you change that magnetic field, the bigger the electric current you get. So if you move the magnet really slowly, you get a tiny little spark. But if you whip it back and forth really fast, you get a big surge of electricity. More speed, more power. Okay, but what about the direction of that current? That's where Lenz's law comes in. And honestly, this is where things get really, really cool. You can think of Lenz's law as, well, as nature's rebellious streak. It says that the electricity you create will always, always fight back against the very change that created it in the first place. And this shows you exactly how that works. Let's say you push the north pole of a magnet towards a coil. Instantly, the coil generates a current that turns itself into an electromagnet with its own north pole facing your magnet. Why? To push it away. It's literally opposing your motion. And if you try to pull that north pole away, the coil flips its polarity to south to try and pull it back in. No matter what you do, it fights you. Now, this isn't just some weird quirk of physics. This is one of the most fundamental laws of the universe in action, the law of conservation of energy. I mean, think about it. If the coil actually helped you by pulling the magnet in, you'd be creating energy from absolutely nothing. Lenz's law is what guarantees there's no such thing as a free lunch in physics. You have to work. You have to physically push against that magnetic resistance. And that physical work you're doing is what gets converted into electrical energy. So we have this amazing principle, but how do we get from a little lab experiment to something that could power our entire world? Let's look at how this idea was scaled up to create the true engine of our modern civilization, the electric generator. The next huge leap in thinking was this. Instead of pushing a magnet back and forth, What if you did it the other way around? What if you rotated a loop of wire inside a stationary magnetic field? That gives you a much more efficient, continuous change.
So, as that coil spins, the amount of magnetic field passing through it is constantly changing. When the coil is parallel to the magnetic field, like in step 1, it's cutting through the most magnetic lines. That gives you the biggest change, and you guessed it, the maximum current. Then, as it rotates to be perpendicular to the field in step 2, the change drops to 0, and so does the current. This constant rotation, going from max current down to 0, then to max current in the other direction and back to 0, it naturally creates this beautiful rhythmic pulse. And that pulse, that's what we call alternating current, or AC. It's the electricity that powers our homes. And what's just mind-boggling is that this elegant cycle, this spinning motion, is happening right now, all over the planet, inside countless generators powering pretty much everything you can see. All right, so let's quickly recap the big ideas here. First, electricity and magnetism, they're two sides of the same coin. The secret to linking them is change. A changing magnetic field is what makes an electric current. Faraday's law tells us how much current we get. The faster the change, the more juice. Lenz's law tells us the direction. The current will always fight back. And all of that comes together to form the foundation of literally all modern power generation.
You know, every single time you see a giant wind turbine spinning in a field, or you think about the massive turbines inside a hydroelectric dam or a power plant, you are looking at Faraday's discovery in action. Every single one of them is just a really sophisticated way of turning motion into a changing magnetic field, and that changing field into the electricity that's flowing to you right now.
In the end, Faraday's work was all about making the invisible visible. He took this force that no one could see and figured out how to turn it into a current that completely reshaped humanity. And it kind of leaves you wondering, what other invisible forces are all around us right now, just waiting for the next curious mind to come along and find a way to harness them?